Hi, my name is Jonas Hines, and I'm an epidemiologist. Today, I'll be going over how to do an epidemiological analysis from a field investigation using an AI chatbot. I'll be working in RStudio and doing all of the analysis on my own machine, but using the AI chatbot to help me write code and also understand my findings. This demonstration requires some working knowledge of R, but also will hopefully demonstrate how AI is really powerful and good at writing code and can help us extend our skill set when we need to do analysis. I also hope that this demonstration will emphasize the importance of human oversight for AI output and not just accepting whatever output the AI tool gives us. There are other ways to do this kind of analysis, like uploading the data to a chatbot or using an AI agent to do the analysis for you, but I won't be covering those today.
So this shows the exercise that we're going to go through. Again, this is a foodborne outbreak in a fictional town called Zaza in May 2026. And I'll just read this scenario part 1 to set the stage. You are a field epidemiology trainee assigned to lead a team investigating an outbreak of gastrointestinal illness after a celebratory event in Zaza town on 18th May 2026. 60 people attended the event and over half became sick within a few days. Many were hospitalized and a few died. Apart from the event attendees, the local health department did not report an increase in similar illnesses in the general community served by the hospital. Your team worked with the local health department staff to collect data from attendees. Everyone has been busy collecting data, and it's late in the evening before you are able to open the data set and begin the analysis. So the assignment is, using R and AI chatbot of your choice, complete the following questions. When using a chatbot, upload only the information needed for the task, such as variable names or a small sample of values, unless you have approval to share the data set. Okay, so we're going to start with question number 1, which is to inspect data set 1 and look at the data quality issues. So let me go ahead and open that. Data is quite dirty. This is a common problem during outbreak investigations. When different people are collecting data, they may record certain variables differently. For example, if we look at the symptoms onset column, we can see that there are many different date formats used, and this can oftentimes cause a big headache when we're trying to clean the data. Additionally, all of the other variables look like they have dirty data. For example, in the age column, some people recorded units and some people did not. For all of the symptoms, we can see that different variations of ones and zeros, yeses and nos, Y and true, false were used to indicate whether or not a symptom was present or not. So this data is going to require a lot of cleaning. So luckily, AI can be really helpful when we need to clean data, which can oftentimes be a rate limiting step for doing analysis. So on my screen, I have a chatbot, ChatGPT, open on the left, and I have RStudio opened on the right. The first thing we're going to do is just import the data. I've already written this code, and I'm just going to paste it in. But if you're doing this, you may have to type it in first. Now, I want to emphasize that this demonstration requires some familiarity with RStudio, and we're not going to cover that during this demonstration. So the first thing I'm going to do is import a few libraries that I'm going to use, and then I'm going to import the data. If I take a look at the data set, I can see that it looks similar to what we just looked at in the Excel file. And one thing we want to do is just take a look at the structure, which is the variable names. And so we can see here that the data set includes patient name. Now, one thing you never want to do is upload personally identifying information or protected individual information into a chatbot because that's considered privileged information. So we have to go ahead and remove that variable from our data set before we start working with a chatbot. So here I do that. I'm just going to confirm that there's no longer in our structure, there's no longer a patient name. That was the second variable, so we can see that that's been removed. Now, one other thing I noticed, though, is that some of the variable names are going to be difficult to work with in R. For example, abdominal pain has a capital letter and then also a space, as does bloody diarrhea. So I like to clean my variable names before I start working in R. So I'm going to go ahead and do that. And I'm going to take a look at our variable names now. And we can see that everything is now lowercase. And if there was a space, there's now an underscore. So the str or structure function in R lists out the variable names with a $sign in front, the type of variable, this one being character, and then the first few observations of that variable. So here's the first observation. Before I start working in a chatbot, I like to do what I call priming the chatbot, which is basically just pasting this screenshot of this structure into the chatbot so that it knows my variable names and that any code that's going to help write for me is going to have those variable names in it, and I won't have to worry about changing them once I get it onto my machine. So I've taken a screenshot of the R console that shows the variable names. I'm just going to paste that into the chatbot, again, so that the chatbot is familiar with the variable names. And then I'm going to put in my first prompt. And for this, I actually just copied the scenario that I read earlier about the outbreak, just to give sufficient context to the AI chatbot about what we are doing. I then added a bit more information here that I'll read out loud, which says the local health department has shared a line list of cases with me. The data are dirty. I am uploading the data structure to this chatbot. I would first like help cleaning the data set so that responses are standardized. Please write R code to clean this data. Do not alter any original variables in the data set. Create new variables only. Add cross-tabulation so I can visually inspect the recoding and ensure accurate data cleaning. Use tidyverse packages for my analysis. So here I've specifically given instructions what I would like the chatbot to help me do. And then I've also given constraints. I don't want it to write any code that's going to overwrite existing variables. I also would like it to do quality assurance checks that I can visually inspect so that I can make sure it's recoding correctly. And then lastly, I've also specified the packages that I would like it to use for this code. So I'm going to go ahead and run that. The chatbot wrote this code that we're going to copy and paste into our R script. Now I've already gone through the code to ensure I understand what's happening along the way. It's important to have some familiarity with the coding language you're working in so that you can ensure you understand what's happening in case you run into any issues, and also just to ensure human oversight. In the interest of time, I'm just going to run this entire code chunk to show you the output. So the chatbot helped create this table, which shows all of the variables and how they are recoded. We have a column for original variable, what the original value was, the clean variable name, what the clean value was, and the frequency. We can see that, for example, for the symptom abdominal pain, no was converted to no. It wasn't changed at all. There were 7 of those observations, but false was changed to no. And we can look through all of the different variations of the responses and basically confirm that yes, the chatbot correctly recoded these as yeses and nos. You can also see that for age, there were some original values that included units, and these have all been stripped. So now we just have numeric age for all the variables. And as we're looking over this, we just want to confirm that there was no things that were misinterpreted. But eyeballing all of this, we can see that the code has correctly cleaned the age variable. If we look at symptom onset date, we can also see that all these varying versions of date formats have all been correctly cleaned to the correct symptom onset date. This is a huge help because oftentimes cleaning dates can be one of the most time-consuming aspects of cleaning a data set. Now, not all of the variables were successfully cleaned on the first pass. For example, if you look at occupation, we can see that here HCW, which stands for healthcare worker, was just changed to HCW, but lowercase. we ideally would have seen that change to health worker, like the next row. Additionally, market trader stayed as market trader, whereas we know that that probably should be converted to a trader. This emphasizes an important aspect of working with AI to clean data, which is that you need to oversee the output to ensure that what you expect to happen is actually happening, so that you don't accidentally introduce errors that come back and are problematic later on. I can tell you that for occupation, outcome, residence, sex, and test result, there's still some additional cleaning that needs to happen. So this leads us to our first iteration, which I'm just going to paste here. It states, this worked well for most variables, however, several need some additional attention to be cleaned. Village, residence, sex, occupation, test result, and outcome. See attached screenshots of the current output. Please clean further. Output a new full chunk of code, but do not change the way cleaning or QA checks were done from the previous code. So here I've uploaded screenshots of those variables, but I haven't actually specified to the chatbot how I would like it to clean those variables. In my prompt, I specifically told the chatbot to output a full new chunk of code, just so it didn't give me a patch that I had to then go find where to put in. Now I'm just going to copy this code and paste it back into our studio. And now looking at that same table as before, we can see that, for example, healthcare worker, or HCW, is now changed to healthcare worker as we expected. Market trader was now changed to trader as we expected. If we look through the other variables, we can also see that the chatbot has understood, just by looking at the output, how it should clean the variables correctly and how we would have cleaned them if we were doing this manually ourselves. Outcome is now died or recovered. The villages are all now correctly grouped, so there's just 3 villages. Those variations of male and female have been cleaned correctly, and the test result variable now has been cleaned as we expected it to. Now we have a clean data set that the chatbot has helped us create, so we can get into analysis, which is a lot more fun. So let's go ahead and do question number 2 on the on the exercise, which is to using a clean data set to create a table showing the main demographic characteristics. So we can insert our prompt into the same chat, and basically says, I copy the question, just says to do that, and then I specify the package I want. So the chatbot has written the code. We're going to copy this over and paste it into our studio and go ahead and run it. Again, I've already looked through this code to ensure that I understand what's going on, but let's take a look at our table 1. It looks pretty good. We see demographic variables listed. I notice here under residence that for nominal variables, they've just ordered them alphabetically, which is the default, but we might want to flip those around so that they're ordered in order of decreasing frequency. The same is true for occupation. Symptoms are listed as just binary variables, so they're in order of how they appear in the data set and not in order of decreasing frequency. And then test result also is ordered alphabetically and not in any sort of specific order. So we might want to make some minor adjustments to this table 1, but overall it looks pretty good. And so we're going to go ahead and do an iteration to try to get exactly what we want. Pasted our iterated prompt in the chat. It says, this looks great. Please make the following updates. For nominal variables, show them in order of decreasing frequency rather than alphabetically ordered, except for test result, which should show the positive results first and decreasing frequency, then negative, and lastly, not tested responses. Condense individual binary symptoms variables into a single variable and show according to decreasing frequency. Remove date of symptoms onset variable, and bin incubation period days into fewer responses. Let's go ahead and run that. And now let's go ahead and copy this code over to RStudio and run it. So the code threw an error, which is actually a good opportunity to demonstrate how we can use the chatbot to debug the error. So I'm going to go ahead and copy it and paste it into the chat. So we go ahead and paste this patch into the symptoms table section that it instructs us to. And then we can just run this code all the way down to table 1 just to regenerate our new table, which is shown on the screen. Ordinal variables like age group were unchanged by our modifications, which is what we wanted. But nominal variables like sex, residence, and occupation now show the most common groups at the top and a decreasing frequency, which is helpful for viewers to understand what the most common groupings were. Additionally, incubation period was binned as we requested, and test result now is ordered according to our specific requests, where positive results are shown at the top, then negative, and then not tested. Lastly, symptoms are now all in one variable and in order of decreasing frequency, which is helpful to understand what the most common symptoms were during this outbreak. Back to the assignment, we can see that the next task is to create an epidemic curve. So I just post those instructions in the chat and run it. And copy this code over to my RStudio and run it. Here's what the epidemic curve looks like. Overall, not bad. A couple things I might want to update. One being that the event date occurs on the very first value on the x-axis. I'd like to have a bit of padding there. Similarly, I'd like to have some padding after the last case, just to show that no more cases had been reported. Additionally, just using the grayscale is not great. I'd like to maybe give a little bit more color, and then also get rid of those grid lines in the background, which are just distracting. So I go ahead and paste those updates as an iterated prompt that reads pad either side of the x-axis so the event date is clearer, and also that there are no later cases observed. Make the epi curve more visually appealing with color and with less chart furniture, e.g. grid lines. So let's copy this code over. And here's the updated epi curve. So it's followed our instructions, and overall it looks pretty good, and is asking us to interpret the data analysis so far. And remember, this should primarily be done by humans, especially new learners who are building experience and learning about epidemiology. But for the purposes of this demonstration, I want to show how a chatbot can also help us think about data and data analysis and interpreting the results. Up until now, we've just been doing the analysis locally on our machine, but this step is going to require us to paste some of our findings within the chatbot. My prompt reads, inspecting the table, what observations stand out to you? The table is pasted in the chat. And here I'm just literally copy, cut, and pasting the table from the R viewer here into the chat. And even though the formatting is off, the chatbot will be able to interpret it. So here's the chatbot's interpretation. The outbreak appears severe. More than half of patients were hospitalized, and there were 3 deaths, which is substantial for a foodborne outbreak. The illness looks like it was diarrheal and primarily inflammatory. The incubation period argues against a toxin-mediated, and it's likely a bacterial enteric infection. Laboratory results suggest E. coli, although testing was incomplete. And then lastly, it tells us that this table describes cases only, and it recommends that we do an analysis of food exposures amongst ill and non-ill attendees at this event, which is what we'll do next. Scenario part 2A, as part of your field investigation, you develop and deploy a questionnaire that collects detailed food histories from some of the people who attended the event. So let's take a look at that data, and we can see here that there's a unique ID, and then there's a bunch of responses to whether or not they consumed specific food items that were served at the event. We can see here that the food exposure data was collected using a digital standardized questionnaire, so the data is already standardized and cleaned. Our next assignment is to merge the food history data with this line list data using the unique ID, EPID. That information into the chat, and I'm going to run it. I'm going to copy this code and run the code in RStudio. So if we take a look at the merge data, we can see that it contains the cleaned variables from the previous exercise and then the food exposures. But there's only 35 observations, which was the number of people that were in the line list. And if we look at the original food data set, there's 55 people because we've collected food histories on some people who weren't sick. So there's a problem with our code. So I paste this iteration in the chatbot. This code generates a merged data set that only contains cases from the line list, dataset 1, which has 35 observations. To compare attack rates by food exposure, we also need the food history from non-ill persons that are in dataset 2, which has 55 observations. Please update the R code to ensure all 55 persons are in the merged dataset so that we can compare exposures between ill and non-ill. So we review this code and paste it into RStudio and run it. Now we can see that there are 55 observations in the merge table and that persons who were not cases have missing demographic data because they weren't in the original line list. The code also contains some QA checks. We can run those and see that, for instance, there's 35 ill and 20 non-ill. So the next task in the assignment reads, you decide to conduct an epidemiologic study to identify whether a specific food item was responsible for the illness. What kind of epidemiological study would you conduct given the outbreak characteristics? So let's post this in the chat. And we can see the response from the chatbot is instructing us to do a retrospective cohort study, and it gives the rationale. The exposed population is well defined, the denominator is known, both ill and non-ill attendees can be included, and the key measure of association is the risk ratio. It shows us how to calculate that, and then it says here, a case control study would be less appropriate here because the cohort is relatively small and identifiable. It would be considered only if you could not obtain food histories from a meaningful number of non-ill attendees, or if the attendee list were incomplete. Another point to make, which maybe was missed by the chatbot, is just that because so many of the attendees were sick, if we calculate odds ratios, they're going to overestimate the associations compared to risk ratios. So the next question is to estimate a measure of association for the different food items. What is the likely vehicle for this outbreak? So I paste that into the chat and run it, and copy the code and paste it into RStudio. The chatbot annotates the code and explains what different steps are doing, which is really helpful to understand and follow along. So after I'm done reviewing the code, I run it and can see the output in this nice table, which shows the food item is rows, and then as columns, the numbers of exposed, the attack rates, the risk difference, the risk ratio, and the p-values, and it's ordered these according to the p-value. So we can see that chicken is statistically significantly associated with illness, with the risk ratio of 2.08, and the 95% confidence interval does not cross 1. We can also see that cabbage is statistically significant, as well as rice is on the borderline. So it looks like chicken is the likely cause of this outbreak, but we want to go a bit deeper. The next question says, despite chicken being the implicated food, some ill patients did not report eating chicken. How is this possible? Of course, with new learners, we want them to be thinking through potential reasons on their own before utilizing AI. But for the purposes of this exercise, let's see what we get. So I already pasted this question number 8 into the chatbot, and then I also copied the table from the RStudio viewer and pasted that into the chatbot. We can go ahead and take a look at the response. So it says, chicken can still be the likely vehicle, even if some cases did not report eating chicken. The key finding is not that chicken explains every illness, but that people who ate chicken had a much higher illness risk. And then it gives the statistics. And then it gives us 6 potential explanations for why ill persons denied eating chicken, and they're all pretty good. One is exposure misclassification. They just may have forgotten. Potential cross-contamination, a shared preparation or serving step, potentially secondary transmission, just non-outbreak background illness, and then some other co-contaminated food. So pretty useful differential explanations for why some ill persons did not report eating chicken. You also observed that cabbage was significantly associated with illness. How do you interpret this finding? So let's run that in the chatbot. So here, the chatbot is looking at the results and it's saying cabbage is statistically associated, but it had a lower attack risk or lower attack rate. So this does not implicate cabbage as the likely vehicle. If cabbage were the likely vehicle, you would expect the attack rate to be higher amongst people who ate cabbage. So the risk ratio should be greater than 1. And then it gives a good differential explanation for why that might be. There could be confounding by food choice or meal pattern. So people who ate cabbage may be less likely to eat chicken. It could be a marker of a lower risk serving pathway. So potentially having to do with where the food was placed or the utensils that were used. It could just be a chance finding, right? We're doing multiple comparisons, and so there just could be a statistically significant finding by chance. Or there could be recall reporting differences. People may remember eating certain foods more than others, and cabbage is potentially a side dish. Associated with illness in this outbreak, even though only a small number of people reported eating it. How would you interpret this finding? So I already entered this into the chatbot, and so we can just go ahead and take a look at its response. But it reads, rice has an elevated crude attack rate, but it is a weaker and less convincing vehicle than chicken. It reports the statistics from the table. And then it says, rice eaters had a higher illness risk than non-rice eaters. So rice may be associated with illness. However, only 17 people ate rice, and only 14 out of 35 cases reported eating it. This means rice alone does not explain most cases. The chatbot then goes on to give 4 useful potential reasons why this might be the case. Confounding by chicken consumption. So people who ate rice may be more likely to have eaten chicken. Cross-contamination. That rice is a true secondary vehicle. Or just the simple fact that our sample size is small. And most importantly, it tells us that our next step should be to stratify the rice association by chicken consumption. So that's what we'll go ahead and do. So I just ask the chatbot to please write the R code to do a stratified analysis of rice consumption by chicken exposure. So the chatbot generates the code. We're going to go through and scan to make sure we understand what's happening. Once we've done that, we're going to copy the code and paste it into RStudio and run it. We can see that there were 14 people who were ill and ate rice, and all 14 of those people also ate chicken. So if we look at the stratum of people who ate chicken, and then whether or not they'd eaten rice, we now see that the stratified risk ratio is essentially 1, meaning there's no difference. But let's see what the chatbot thinks about this. So I wrote the prompt. The output from the stratified analysis is below. I think this suggests the rice finding was confounded by chicken consumption. What do you think? And then I just pasted in the results from the table that we were just looking at into the chatbot. And the response is helpful. It says, yes, this output strongly supports the crude rice association was confounded by chicken consumption. It says the crude risk ratio is 1.49. But among people who ate chicken, rice has little association. The risk ratio is 1.08. And it says the most important detail is that all 17 rice eaters also ate chicken. So scenario 3 reads, the hospital laboratory in Zaza town has microbiology capacity to perform bacterial culture on clinical specimens. Several patients linked to this outbreak and admitted to Zaza Town Hospital had stool specimens collected with the results shown below. The question is, why do some ill patients linked to the outbreak have a negative stool culture? Why do several cultures have bacteria other than E. coli detected? So let's put this information in the chatbot and see what it says. So the response is shown here, and it says negative or non-E. coli stool culture results do not rule out outbreak-associated illness. And then it gives some reasons why ill patients may have negative stool cultures, including that the specimen timing was late, so they've already cleared the bacteria from their GI tract, that they may have been received antibiotics, and that reduces the yield of a culture. Specimen handling issues could lead to reduced viability, that routine cultures may miss some causative organisms sometimes, and that the illness may be outbreak compatible but not laboratory confirmed. So people can still be outbreak cases even if they don't have lab confirmation. There's also some explanations as to why other bacteria may have been detected, including that there's mixed contamination of the implicated food, there's cross-contamination, there's just background and enteric infections occurring in this population, or that, and then it mentions that, positive for E. coli is only part of the way there, and we need to do some additional testing. Lastly, it includes a useful field interpretation summary, which basically says that although this laboratory results support E. coli, that the signal is not perfect, but that's to be expected, right? We're working in the real world, and data is not always perfect in that setting. So that they recommends that we send isolates to a public health laboratory to undergo toxin testing, serotyping, or molecular subtyping. So the last scenario, scenario 4, reads, positive specimens were transported to a nearby city with advanced diagnostic capacity for further testing. Genomes from 8 sequenced E. coli specimens are closely related, providing further evidence that the outbreak was related to a common exposure at the event. Are there any other steps you would recommend for this outbreak investigation? So let's put that into the chat and see what response the chatbot gives us to this question. And we can see here some of the responses that the chatbot provided, which are overall pretty good. So first is just to further classify the cases as confirmed, probable, or non-cases. Continue to try to gather information from the people that we didn't interview. Remember, there were 60 people at the event, but we interviewed 55. I'd also suggest re-interviewing the 8 persons who reported no chicken exposure but were ill. Recommends doing an environmental assessment, potential trace back of the implicated chicken, as well as testing leftover food if it's available to see if it has the causative organism detected. Additionally, it recommends that even though we did the sequencing in this example, that we should still do the toxin testing and the serotype and toxin testing. And then it recommends maintaining active surveillance and case finding for additional cases, giving guidance to clinicians to think about this illness since we've seen cases, and then basically communicate our findings. So overall, pretty useful list of steps to continue for this outbreak investigation. I hope that this example demonstrates how really you can use a chatbot alongside as you're working on an analysis, and it can really be useful both for cleaning data, helping to run analysis, and then also helping to understand your findings. One thing you may have noticed, though, is that as we were putting all this code into our studio that the chatbot had generated, there's lots of redundant code being generated. For example, each time we asked for a new chunk of code, it would give us packages to load, but also there's some variables that get recreated several times in the code if you were to look more closely. So whenever I'm done working with like in a situation like this where I'm using a chatbot to help code, I like to ask the chatbot to output a final code that basically cleans up what it's worked on. So let's go ahead and do that. Paste this in the chat. And my prompt just says, now please clean entire code from this chat session and return it as one chunk for me. The output from that prompt. But you'll notice that it actually is not rendering well. I don't know if this has to do with like how much we've already done in this chat, and maybe we're reaching our context window max. But this is basically just a single line of code with the entire code in it, so it's not really useful the way it is. So, this is one of the funny things about working with AI is it can be pretty unpredictable and do kind of insane things sometimes like this. So then I entered this chat. This isn't rendering well in the chat window. It just shows a single line of code. Please fix so that I can easily paste into RStudio. So instead of generating the script within the chat like it had before, it just made an R. It just made a file. Basically, this is the entire code, and just copy it and then paste it into our running code. And so I don't know if you guys caught that, but basically the initial code we had written over the course of the exercise was about 2,000 lines, and then this consolidated code basically breaks it down to 1,000 lines. So it does make it substantially shorter and would be easier to follow in the future if you were opening up the code again. Of course, we would go through and make sure that we understood what the code was doing and that it ran correctly. For this demonstration, I'm just going to go ahead and run the entire code, and we can just see that it runs successfully. So it's going to take a second. So the code successfully executed. There were no errors, and we can see that it's recreated the tables that we had previously built one by one through the exercise. And this just emphasizes the advantage or the benefit of using AI for coding. You don't have to necessarily be deeply familiar with the syntax to be able to do the analysis. Statistical code, computer code is highly structured. It's convention heavy. It's repetitive, and there's lots of existing documentation on coding that exists within the corpus of knowledge that these LLMs are trained on. And for that reason, these LLMs are really good at coding. And so the purpose of this exercise was really just to show how you could try to incorporate a chatbot into your practice if you're a field epidemiologist, and hopefully this was a helpful demonstration.
So thanks for joining me for this demonstration today of how you can use an AI chatbot to help with coding in RStudio for an epidemiological analysis. The main takeaways from this are that AI can really help us with coding if we know how to use R a little bit, and that even though it can help write the code, it's important that you provide human oversight to ensure that it's doing what you expect it to do, that there's not hallucinations occurring, and that the output is valid. In the end, it's what you put out. It's whether or not you used AI or did it yourself, you are going to be responsible for that output. So ensure that you are looking over it and you are providing the human in the loop oversight of AI outputs when you're using it. Additionally, I used it pretty heavily to help with some of the data interpretation, but as you're learning to be a field epidemiologist, first trying to think through those explanations yourself is going to help build that knowledge, that judgment, and that intuition that you're going to need to practice as a field epidemiologist in the future. So do be developing those skills alongside of your AI usage skills too.